Hello everyone! Welcome to Team 26010's project video. We are partnered with Sargent Aerospace and Defense to create an automated coolant, monitoring, and refill system. This is our poster, which has several major sections, including the project overview, goals, design, results, and methods. We aim to create a system that integrates both hardware and software to control and read cooling conditions. Our modular design has 3 subsystems and 2 programmable logic controllers to take in readings. Overall, results are the creation of our electrical enclosures and automated prototype that toggles between manual and auto modes. We have tested by checking for accuracy, sample rate, and the validity of PLC communication. Hello everyone, this is Team 26010 and we are the Automated Coolant, Monitoring and Refill System project. My name is Isabel Lee and my teammates are Rolando, Brad, April, Derek, and Abdullah. We are working with Sargent Aerospace and Defense to create an industrial coolant control system that has a PLC, which stands for Programmable Logic Controller, industrial sensors from Coolant, and we are also using Ignition SCADA, which stands for Supervisory Control and Data Acquisition Platform. So this allows our technicians, such as the end users, to look at the individual sump from a single station without having to personally go and check on each sump. And last but not least, our team also consists of 3 industrial engineers, 2 electrical engineers, and 1 mechanical engineer.
Now moving on to our problem statement. Currently, techs are going around to each machine checking the coolant level and taking a sample for the concentration. This takes a lot of time to go around to each individual machine when there are about 30 on the floor. Our project aims to give techs one individual screen to be able to check multiple machines at once so they don't have to go around to each individual machine. Here we have our system block diagram. You can see that it has 3 subassemblies: the HMI subassembly, the source subassembly, and the sump subassembly. All three subassemblies are connected via one wire or hose. Now we're moving into our point design, which is similar to our system block diagram, but it shows our components in a little more detail. Here you can see it. We start at Ignition HMI, we then move to the source PLC, then to the radar level sensor inside the coolant drum to monitor the level of the source coolant. The coolant is then picked up by the dosatron chemical injector, sent through hoses and valves into the machine sump, where then the level and concentration are checked by the sensors inside the machine sump. The data from the sensors is then sent to the sump PLC, which is then sent back to the Ignition HMI, creating a full loop in our system. Now moving on to the project goals, we're looking to provide a scalable modular interface for the techs to check the machines that checks the coolant, the concentration, and the level of the source of the CNC machines, as well as checking the coolant level in the source drum of coolant that will be supplied to the machines.
In terms of requirements, our main requirements stem from the system having the capability to autonomously adjust coolant levels and concentration in the machine coolant sump to specified quantities, along with monitoring source drum levels. Accuracy-wise, the system shall refill coolant level with a 5% tolerance and control coolant concentration with a 2% tolerance. This is based off sensor sample rates, which should log data every 30 seconds in the source and every 10 seconds in the sump.
Thank you, April. I will now be going over the system layout demonstration, where I will be demonstrating the main components and their functions.
Hey everyone, we're going to start going over our system layout now. What we're doing here is recreating the final system that will be implemented in Sargent's manufacturing floor. We do this with aquariums to recreate the CNC sumps, alongside these 2 electrical enclosures on my right and left, which hold the PLCs that control our pumps, valves, chemical injector, and sensors. Sensors being 2 level sensors as well as a reflectometer sensor.
Some of the main components in our system are the programmable logic controller from Automation Direct, our key and sensors, which include level, concentration, and temperature, and our pumps and valves, along with their power supplies.
Now we have the 2 sensors right here reading the concentration and the level of the sump. Right now, the system is reading that the concentration is too low, which is why it's drawing in coolant from the pump through the chemical injector and into the sump. Now, this pump right here, it's used to mix the whole mixture. It's drawing in the coolant from one side and spraying it from the other.
Hi everyone, this is the run through of the ignition GUI that technicians will have access to. First, we have the source level, the sump level, the red concentration of the specific sump, and technicians are also able to set a specific concentration. So here we can read temperature, level, concentration. In addition, we can toggle between the auto and manual modes. So if you click manual, you will be brought into a screen where you are able to manually start the refill, stop the refill, or cancel to go back to the auto mode.
This is our source of assembly enclosure. They have been assembled based off a connections document being shown on screen, and they encompass our PLC, power supplies, terminal blocks, and relay. We also have our sub-assembly enclosure, which encompasses the same main components along with an Ethernet pass-through and has labels for each wire based off the connections document.
Now, we want to share some of the challenges and lessons learned from this project. Starting from our industrial engineers, we have Brad.
Something I learned is working with teams with people that I'm not very familiar with.
And next, we have Abdullah, who is representing our electrical engineers.
What I learned is how to make an automated system. So we never learned that in the university. So learning how to make an automated system was so much fun and so much interesting.
And lastly, our mechanical engineer.
Yeah, so besides making the entirety of the project work to get all together properly, I believe learning new softwares for mechanical modeling, especially for the wiring systems and electrical systems, was one of my biggest challenges.
In conclusion, all of our major goals were met in terms of controlling and reading coolant levels, concentration, and temperature within a single CNC machine sump. Additionally, we will also be delivering our operations and maintenance manual, test procedures including the data sheets, and also the physical prototype, which includes our electrical enclosures, sensors, and other miscellaneous parts such as the hoses and also pumps and valves will be provided. The future plans stemming from our prototype include scaling up the number of possible sumps in our prototype. So currently it's only doing a single CNC machine, but with the modularity in our design, it will be easy to scale this up. That is all from our project. Thank you.